The regression plots in Seaborn are intended to visually show you how closely correlated two variables are from each other. It adds a regression line onto a scatter plot, and that line is supposed to be the best fit across all of the data points. It's associated with a correlation coefficient, which is a number between -1 and +1. +1 represents the strongest positive correlation, and -1 is the strongest negative correlation. The closer to 0 the correlation coefficient is, the weaker the correlation. So let's look at three examples. The chart on the left has a very strong correlation, so the line of best fit looks like this. The correlation coefficient is, let's say, 0.9. That's a strong positive correlation. The chart in the middle doesn't really have a correlation. The line is horizontal. That means an increase in x leads to no increase in y. Hence, there is no correlation. In the chart on the right, there's a negative correlation, and that's why the line looks like that. If you increase x, then y actually goes down. Okay, so let me run you through my data preparation. I've imported pandas as PD, matplotlib.pyplot as PLT, and Seaborn as SNS. And I'm using the penguins example dataset again. Okay, so before we look at the charts, let me show you the core method in pandas. This method returns the correlation coefficient for the numerical columns in your data frame. By default, it uses the Pearson method to calculate R, where R is the correlation coefficient. If you're interested in the maths, the formula is here. I've done an example at the end of this notebook for you to review if you're interested. I've recalculated the Pearson correlation coefficient, which is calculated here using the core method, using the formula. So if you're interested to see how it works, you can review the notebook. Okay, so let me perform the core method on the penguins data frame. You just type penguins.core. So what we have is a sort of matrix. The numbers displayed are the correlation coefficients. So for example, 0.656 is the correlation coefficient for the bill length and the flipper length. Diagonally, you have a series of 1s. That's because they're the same variables. Bill length versus bill length will always have a correlation of 1 because they're the exact same values. But what we can see here is that there's a negative correlation between the bill depth and the flipper length. There's also a negative correlation between the bill depth and the bill length, but that's a weaker correlation because it's closer to 0. The strongest positive correlation looks to be between the body mass and the flipper length at 0.87. So let's confirm what we've seen with a reg plot. The reg plot will take two variables and produce a scatter chart with a regression line. It also produces an error band with a confidence interval of 95%. You can review the documentation and other arguments by following this link in your own time. Okay, so let me plot a reg plot. We saw that the Pearson correlation coefficient for the bill length and flipper length was roughly -0.6. So let's visualize this. So plt.figure, fig size equals 10 by 10, and then I'll type sns.regplot. For x, I will have flipper length mm, y will be bill depth mm. Data will be penguins. So as you can see, it is in fact negative. The transparent bands represent the confidence intervals. So it's saying with 95% confidence, the true mean of a point will lie within these bands. You can remove it by typing ci is equal to none. Okay, so now let's confirm there's a strong positive correlation between the flipper length and the body mass. Indeed there is, as you can see from the direction of the line. One final regression plot I want to show you is the LM plot. This can plot a regression plot across a facet grid. It takes col and row as an argument, just like displot and rel plot. It also takes height and aspect for its size. So let me perform an LM plot for flipper length and body mass. So I can just type sns.lmplot x is equal to flipper length mm, y is equal to body mass g, data is equal to penguins, and I'll say CI as none, height as 5, aspect as 1.5. Put a typo there. Make this a little larger by saying the height as 8. Okay, so no change here. It looks just the same as the reg plot. But now let me pass in an argument of island for the row and sex for the col. I'll adjust the height too, so that it's smaller. And then I will add row equals island, col equals sex. Let me make this smaller. Okay. So what we can actually see here is that the strongest positive correlation looks to be in the island of Biscoe, and there seems to be a stronger correlation with the females than there is with the males, even though they're both pretty strong. The other islands don't really have much of a correlation. As you can see here, the line is pretty horizontal, and it's quite weak here, as well as here, and here as well. Okay, great. So that was regression plots in Seaborn.